Okay, so we are starting the first section of Chapter 1. We're going to model and do some equation solving, which is all stuff you've done before. So there's nothing new in this section that you haven't learned before. Hopefully we can get some more review on solving equations. So I've got some homework, that's some random problems of solving equations. We'll look at some numerical models, algebraic models, graphic models, the zero factor property. You know what all these things are. You've done these in the past. You know, you set up number models and algebraic models of equations, and you've looked at graphs. You've done problem solving. You actually know what the zero factor property is, but you probably don't know it by name. One thing we'll look back at again is not to rely too heavily on your calculator, because sometimes your calculator lets you down. And the reason why is because these numerical, algebraic, and graphic models give us different methods to visualize, analyze, and understand data, which helps us understand the world we live in. So a mathematical model is just a structure that approximates phenomena for the purpose of studying and predicting their behavior. There's two types. There's numerical and algebraic, which are things that you're actually comfortable with. Let's set up a mathematical model to solve this example then. A pizza sells a rectangular pizza 20 inch by 22 inch for the same price as a round pizza with a 24-inch diameter. If both pieces are the same thickness, which option give the most pizza for the money? So what we're looking at is area per cost. We want to buy the pizza that gives us the bigger area per cost ratio. Okay, so we need to calculate the area of both of these real quick. The first one is a rectangle, so it's just 20 by 22, which is 440. The second one then is pi r squared. For area of the round one, it's got a 12-inch radius or a 24-inch diameter, so that'd be pi 12 squared, which gives us about 452.4. So this one gives us more area for the same cost, because they are the same price. So because it has more area, then that one obviously will be the better option. This is an example of a numerical model. Then we did a numerical model to determine what the better deal is for buying a pizza. Stuff you've done in the past. Okay, let's look at a graph model then. It's just a visual representation of a numerical model or an algebraic model that gives insight into the relationship between the variables that are involved. Okay, we'll look at some examples of that in a second. First, the zero product property then. The book gives this. It's just a product of real numbers is 0 if and only if at least one of the factors in the product is 0. So 3 times 0 only gives you 0 if one of the factors is 0. Okay, and that qualifies for linear terms as well, which we'll look at. So let's solve an equation then. It wants us to solve this algebraically. So let's take x squared and let's add 4x to both sides. And let's subtract 8 from both sides as well. Let's try to factor this if we can, because factoring is the quickest way to solve algebraically if we can. So let's do x plus 4. And unfortunately there are no two numbers that will factor this. So we can either use the quadratic formula or complete the square. I guess I'll complete the square because that really is the quadratic formula anyway. We want this over to the other side. We want to add b over 2 squared to both sides. So we're going to add 4 over 2, which is 2 squared to both sides. We're adding 4. This becomes then x plus 2 squared equals 12. We'll square root both sides. We get x plus 2 equals plus or minus the square root of 12. Subtract 2 from both sides, and there's our two answers. And we can simplify this if we want. 12 is really 4 times 3. So this would be 2 square root of 3. So we've got negative 2 plus or minus 2 square root of 3 as our answer, simplified radical form. All right, next the book gives this fundamental connection, which is something you already know, something you've already learned, but just to review it with you. If we have a number that solves an equation that's equal to 0, then you can say these things. You can say it's a solution or a root. You can say that's a 0 of that polynomial, or you could say it's an x-intercept of the graph. Because, you know, like for a polynomial, when it goes through 0 right here, that's either a solution, a root, or an x-intercept. All right, the book talks a little bit about graph or failure. So what it's talking about is if you graph this in your calculator, you get this, which there's no grapher failure here. The new updated TI calculators don't do this, but the old ones, if you have an old calculator, it put like a line right here, and I think it was a full thick line, and it looked as if there was an x-intercept there, if that was part of the function, but it graphed the asymptote basically. The new calculators don't do that. As you can tell, my calculator didn't do that. So if you have a newer calculator, there's not going to be this kind of grapher error right there. All right, here's an example of not seeing hidden behavior. We'll talk a lot about this throughout the year, but we can change the window on our calculator to view different things. This is a fourth degree polynomial, so the graph looks something like this, but depending on your window, you'll see it differently. In this big window, you don't see these curves at all. It just looks like a parabola. This is just a window of the first quadrant, and this window shows you something similar to this, but we can change our windows, so if you want to practice this, graph this, and go ahead and change your windows and take a look at what you see. If not, go ahead and pull up the homework assignment, and let's get started on that.